if you have any questions over the anything over Unit 8, I'll be glad to answer them now. Matt said that a lot of y'all on the homework were missing the half-life formula or the half-life problem. I do have one of those in the review as well as the Kahoot. So, you know, pay special attention to that because it's a little bit different. You have to put the half-life. Remember the numerator of the exponent is the actual time, like if it's going on for 5 years or whatever, and the half-life is the denominator of the exponent. And what the half-life means is that's how long it takes for whatever substance that you're working with to decrease by 50%. So take any questions you have right now, and then throughout the period, same thing. Then we're going to do a Kahoot practice for the final part 1. These questions are very similar to the final part 1. So it would really behoove you to participate. And I'll post these questions on Blackboard as well, so you can look at them again, but for sure write down the answers because I'm not going to post the answers on Blackboard, even though they'll be part of this video. But they're very close to the ones that you'll see on the test tomorrow. And then I'm hoping that y'all did the review or have looked at the review, which has been online for some time. And if you have any questions over any of the problems on that review, and if we have time, we'll go over those questions. And then just study. And the test tomorrow will be just like normal. Hopefully Amazon won't be having, or whatever it was, had so much trouble last time. So hopefully you'll be able to get onto the lockdown browser. And if not, just come on into the Zoom room and I'll take care of you from there. So part 1 is tomorrow, and it will be over what we're doing right now. And then Thursday, Matt will review you for the comprehensive part of the final exam.
Yeah, I was gonna say the half-life problem was the fish problem, so I don't know if that helps.
And I will post these questions on Blackboard if you want to look at them again. But I would hope all of you would be able to play with. It will help.
There's a few people that didn't use the right formula for the interest, but it wasn't provided for them, but they just still.
Yeah.
It's a homework, so y'all should still be able to look that up.
Right.
Provided on
right, because you can look at and remember the formulas that will be provided are the compound interest formulas, but none of the log stuff. You have to know all of that the properties of logs.
Oh, and they were like, that was the one where they were trying to make a really weird point with the continuous versus compounding monthly.
Oh, right.
One was like 4.2 and one was like 4.3.
4.3, yeah.
And so if they wrote anything on there, I pretty much just gave them credit.
Yeah, I was like, yeah, I didn't.
But with that said, I think what they're trying to prove is that increasing your interest rate just by a little bit is more of a drastic sort of increase
than going to. I think you're probably right, but I didn't get that. I was like, because really and truly, I mean, that's true. But if you're working with really huge sums of numbers that compounding continuously, I don't know. Would that make a bigger difference? I don't know.
No, I think it jumps up more when you do.
Even with
large amounts, I think.
Okay.
I could be wrong. I don't think.
No, I don't think you probably are, but
I
know that people think. I know that I used to think. I mean, compounding continuously, compounding infinitely. It seems like it would be so much more than like compounding daily, but it's really not with small numbers, especially, you know. Come on, people, log on for me, please. It'll be the last Kahoot you ever have to take with me anyway. And I'm hoping that by next semester, I'll have figured out some more creative ways to do this.
Yeah, at least I'm teaching the same thing next semester. Not this, but my other class. I already have them.
I'm not doing this class next semester. I'm doing. Oh, I was going to ask you too. When we do the portfolio thing, are we supposed to assume, like in the spring, half of it was not online, so so I'm confused as to like, would I mean, in the summer it was for sure an online course, so I have to fill out that.
Yeah, I hadn't started my thing, to be honest.
It's like, you know, I don't even remember what I did. I'm like, I wish they would do the semester you're actually in.
Yeah, I'm gonna have to try to remember as best as I can on that, but there's quite a lot happening, so I don't know.
Yeah.
I guess there's a lot I can put down. I wonder if they just gave a bunch of spring semesters to see what people were doing. That was out of nowhere.
That was crazy, but and you know what, I was doing a support class, so basically that really was crazy. All right, I'm going to go ahead and start, even though we only have 5 people signed in. So please feel free to sign in at any time. And if you're not signed in, do the problems. It's important. Just like this on the test, find the domain. And I will take it in as an inequality or as in interval notation. Either one is fine.
Oh man, I have to go back and watch those videos to edit them. I'm gonna have to listen to my own voice. That's like one of the dreaded things to do.
I know. I've gone back and looked at some of the videos from class, and I'm like, oh my gosh. Yay! All right. So everyone that answered the question got it. You just take the whatever is after the log, and that you can't take the log of anything 0 or under. So it has to be x is greater than 7. Okay, so in an exponential function, the exponent can be any real number, positive or negative or zero. Is that right? Zero? Except zero. Right? I should have had all real numbers except zero, because in an exponential function, you can't have zero as an exponent.
You can have zero as an exponent.
Yes, you can. You can. I don't know what I'm thinking. Yeah, absolutely you can. Okay, yeah. Sometimes I have a senior moment, but yeah, so I was right. Yeah.
You're thinking the other way around.
So you can, this can be any number, because if it's zero, it's just go. What I was thinking of, it was, and never mind. I won't even say what I was thinking. So yeah, this can be anything at all. So all real numbers, it would be your answer. Remember those two problems, because there was ones just like it on the test. Actually, just like all of these. Evaluate this without using a calculator. Well, as if you could use a calculator. Okay, so remember that log base C1 over C. 1 over C is the same thing as C to the negative 1 power. And when you have the base and the argument the same, they undo each other, and you're just left with negative 1. Good, most of y'all got that good. So log base C1 is equal to something we don't know, but that just means that if you take C to some power, you get 1. So the only place that's true is when C is 0. Anything to the 0 power is 1. Good. So e to the ln1 is just the same thing as, ln is the same thing as log base e. So these two things would cancel out and you would just be left with 1. Okay, so you know that exponent log 1, anytime you have a 1 after log, it's always going to be 0. So that actually is 10 to the 0 power, and anything to the 0 power is 1. Also, a 10 and a log base 10 would cancel each other out. So either way you look at it, you would wind up with a 1. So here we go. So find a function of the form f of x equals c a to the x that fits the data exactly. If you know what you're doing, this should take very little time. Okay, so we got that good. So we know that our C is always going to be the y-intercept. So C is 8. And then to find the A, take any number in the chart and divide by the previous one. So I'll take like 1 divided by 2, which is 1/2. So A is either 1/2 or 0.5. So this would be f of x equals to 8 times 1/2 to the power of x. Okay. So I think sometimes it helps to actually name the points on the graph. And this graph is going upward. So I know that my C is going to be, I know that my A is going to be a number that's bigger than, not fractional. If it was going down, it would turn out to be like 1/2 or something like that. So what I do is I like to just list the points, some nice points that are on the graph. So these are some nice points that are on this graph. And you can see that your C is 4. And then your A, if you take any Y value and divide by the previous one, that would be 2. So this would be f of x equals to 4 times 2 power of x. Okay. Be careful about this kind of problem. So you start out, you know it's going to be log some big blob, and anything that's positive is going to go in the numerator, and anything that's negative is going to go in the denominator. So the 12x will go in the numerator. This 2 becomes an exponent. So I'm going to have 2y in parentheses squared in the denominator, and also the 3z in the denominator. And when I square 2y, make sure you're squaring both the 2 and the y. You're going to get 4y squared. And when you simplify all of that, you wind up with log x over y squared z. So let's see. Most of y'all got number. Oh, so this one is if you didn't square the 2 as well. So watch that. Good, good. So those of you that answered it got it right. So when you're expanding the log, every single variable gets its own log. And if it's in the numerator, it's positive. If it's in the denominator, it gets a negative. And then you just bring the exponents, if there are any, to the front of the logs, and that gives you your answer. One almost just like this on the test. And I ask you for it in exact and also as a decimal. So make sure you know how to use your calculator. Okay, whoever it hasn't answered, if you'll guess something, so we can go on to the next question, not have to wait for another minute and a half. Thank you. Okay, good. Most of you got it. I'm happy about that. Of course, the test is not multiple choice, but so the first thing you would want to do is get this 10 on the other side. Remember that you're trying to isolate this thing right here. So I'd subtract 10 from both sides, and that would give me 2 ln x plus 2 is equal to -8. And then I would divide both sides by 2. So that would give me ln x plus 2 equals to -4. And then I know that this is base e. There's more than one way to do this, of course. So I have e. I'm going to exponentiate it, make those numbers into exponents. So this cancels out. And that gives me x plus 2 equals e to the -4. And then I'll just subtract 2 from both sides, and I get x equals e to the -4th minus 2. And if you put that in the calculator, it should give you approximately -1.9817. So because this is base 5, there's more than one way to do this, but I'm going to take the log base 5 both sides. That gets rid of this. And then I would subtract 1 from both sides. And I would divide both sides by 2. And that's what's the calculator ready form. Yours actually could have looked different than that, but when you plug it into the calculator, you should get the same thing I get. All right, so know that we're using this formula because it says quarterly. The only time you use the half-life formula, the only time you use this one if it says half-life. The only time you use this bottom one is if it says continuously. Otherwise, you use the middle one. And then I usually like to define all the variables first. So the initial investment, which is the principal, is 3,000. Interest rate, make sure you change that to a decimal, is 0.031. the number of times it's being compounded is 4, and the t in yours is 10. So this is what your equation should look like. If you got the equation correct and still got the wrong answer, that's because you don't know how to use your calculator. So make sure that you do. Good. So again, we're using this. Actually, we're wanting to double our money. We want to know how long it would take to go from $3,000 to $6,000. Again, I always define my variables first and then plug it into the equation. And so what I'm looking for is time, how much time it's going to take. So here, the first thing you'd want to do is divide both sides by 3,000. So that would give me 2 is equal to 1.031 to the power of t. And then we could take log base 2 of both sides. I'm going to bring the t to the front and then just divide both sides by log base 2, 1.031. Oops. log base 2 is just 1. And then divide by the log base 2, 1.031 equals to t. And that should give you 22.7 years. Good. Most of y'all got that. So, you know you're going to use the PERT formula because it's continuously. Our principal number we start out with is 3,000. The amount we want to wind up with is 6,000. Don't know what the interest rate is. That's what we're looking for. And the number of years it's being compounded is 10. So this would be our equation. The first thing we'd want to do is divide both sides by 3,000. And that gives me e to the 10r equals to 2. So if I take the ln of both sides, That gives me 10R equals to ln2. And then just divide both sides by 10. And that should give you about 0.069, which is 6.9%.
Have we done the e to the x equals cabin yet?
The what?
The e to the x equals cabin. Solve for x. Get a natural log cabin if you do that.
Oh, the natural log cabin. I'm like, I'm so slow sometimes. I get it now. Okay, so let's look at this one. First of all, I love that joke. Took me a minute, but see, if you say e to the x equals cabin, and then you take the ln of both sides, you get x equals to ln cabin, which is x is the natural log cabin. So over here, a equals p e to the rt is what we're using because we're compounding continuously. We want to know how long it's going to take, how much we would have to invest to get $10,000. So a is 10,000, p we don't know, that's what we're looking for. Interest rate is 0.031 and t is 15. So you really don't need to use logarithms at all in this problem. You just divide both sides by e to the 0.031 times 15. So P is going to equal to, if you just take the 10,000 and divide by E to the 0.031 times 15. That gives you about $6,281. I just totally made this up. I have no idea how much caffeine Mountain Dew has.
I think it's more than 80. 100 milligrams is like about a cup of coffee.
I don't know. I'm like I just said.
Mountain Dew is like packed with caffeine compared to the other soda.
Yeah, it is. I hate Mountain Dew, so I don't like Big Red. I don't like any of those high caffeinated drinks. I'm jittery enough without them.
It's actually pretty close. It's 91 for an 8-ounce can, I think is what it says.
91?
Yeah, for a 20-ounce.
That's quite a bit more.
That's what it says.
But
it's pretty close for 80. Yeah, I quit buying sodas when I go grocery shopping. I haven't done that in years. I lost a lot of weight when I quit doing it too.
When you quit drinking, oh, I can imagine.
Yeah. Like I'll still drink a soda if I go out to a place to eat or something maybe. But
I hardly ever drink any kind of soda anymore. I used to be addicted to Diet Coke, but that's so bad for you. Now I love Topo Chico. That's my go-to drink.
It's probably a good call with this bunch of diabetes that runs in the family too.
Yeah.
Yeah, it's really bad. It's got a lot of sugar in it. It's mainly what it is. I don't think. Yeah, I still drink coffee, but it's not
You put sugar.
equally as caffeine, equally as much caffeine, but not as much sugar.
Yeah.
I put like a tablespoon or two.
I drink my coffee black, and I like it very strong. That's not good either.
Yeah, I usually got to cut it with some milk or something. I've been doing oat milk.
You know,
recently.
I didn't even like coffee till I had kids, and then I had to have it. Okay.
It's too
Most
too
of y'all
acidic.
got it. Good. Okay, so I've given you the formula, and I will do that tomorrow on the test as well. So you won't get any confusion over the denominator. So we're looking for 80 times 0.5 to the 3 over 5.7. The mistake that's most common that I really want you to avoid is a lot of times people will multiply the 80 and the 0.5 first, and then they do 40 to this power, which is totally wrong. Make sure you do the whatever your interest rate is, take it to the power first because of PEMDAS, and then multiply by 80. And you should be in good shape. Okay, most of you got this, good. All right, so if you have an equation where the bases are the exact same, then you can just really just throw away those bases. You could also take the log base 17 of both sides, which would also get rid of the bases. So those, we just throw them away. 3x plus 5 equals 6x minus 7, and then just solve this like the normal equation. Now these on the test, we will actually be asked to graph them and tell me the intercept and the asymptote. You'll have to be able to graph this. Good. All right, so if you graph this, parent function is just y equals 3 to the x. And the y-intercept is 0, 1. And the horizontal asymptote is y equals 0. And then if you shift everything up by 2 units, so the y-intercept would become 0, 3. And the new horizontal asymptote will be y equals 2. So you should be able to graph that. Hopefully you can do that without too much trouble. Then what's the intercept and the asymptote for this? Again, you need to be able to graph this as well. Okay, so you know that the inverse of the function is just, if you just switch the x's and the y's, we know that the original function, f of x equals 3 to the x plus 2, had a y-intercept at 0, 3 and a horizontal asymptote at y equals 2. So the for the inverse function, you're going to have an x-intercept at 3, 0. You just switch the 0, 3 and that becomes 3, 0. And instead of y equals 2, the asymptote is going to be x equals 2. So that's, if you get this, if you get the original function, the inverse should be pretty easy. Also, I have a little bonus question on here where I'll ask you, can you write the equation of this function? And all you'd have to do is, what do you think you would do to be able to write the inverse equation? Can someone tell me what you would think you would do? If the original function is this, how would you find the inverse function? Anyone remember from last unit what we did?
Switch the x and y and then solve
Thank
for
you.
y.
Yes. So we're going to switch the x and the y. And we're going to solve for y. So I'll say 3 to the y equals x minus 2. Okay, so I want to get this y by itself, right? How can I get that y by itself?
Divide the 3.
Can't divide, you're on the right track, but not divide the 3, because that's 3 to a power. How do you get rid of the exponent? What would you do?
Take log base 3.
Thank you. Yes, you would take log base 3 of both sides. And you would get y equals log base 3 x minus 2. And that is your inverse. Okay. And finish this out. Like I said, this is a very good representation of the test, and I'll post the questions, and I'll email y'all all the Kahoot just in case you want to do it again. I know how much you love doing them. Yay, Elliot. Yay, Aurora. And Hunter. Wonderful. Good job, you guys. And I hope even though we only had 6 people competing here, I hope the rest of y'all did it as well. Okay, so we have about 5 minutes or as much time as you want, actually, but does anyone have any questions over the review? I'm going to pull it up. Pull it up on just a second. Okay, so these are what you should know, where and how to use these formulas. Actually, I'll give you the half-life formula in the problem. It'll be set up like the one that you saw that involved the Mountain Dew. You do need to know all of these properties. They will not be given to you on the test. Whoops, we've already looked at this. This one, sorry, I pulled up the wrong one, but that's okay. The review for the whole test. How many things going on here? Here we go. So these are, again, more good practice problems. Do make sure you add these onto the review if you're practicing, because there will be ones like these on the test. And then, does anyone have any questions over any of these that they'd like to see?
I mean, I have one question about like
Sure.
one of the formulas. Like it's called the compound interest formula.
Uh-huh.
I was wondering how you get the n.
So the compound interest formula. Okay. So the compound interest formula is this one, right? So the what you have to know is what each piece stands for, and you use this formula if they tell you quarterly or monthly or daily or whatever. If it's continuously, you use the PERT formula. So this is the starting amount right here. This is the ending amount. This is the number of times you're compounding. This is your interest rate as a decimal. And this is the number of years. So you want to know how you would find the n if you're trying to solve for n. Okay, so let's say I'm just going to totally make something up. So let's say how long, how many times you know what, we could do this, and I'm happy to do it, but I'm not asking you to, I'll never ask you to find, I'm not going to ask you to find the n, but let's just look at it anyway.
I mean, yeah, that's fine. I was just saying like,
yeah, because it's in two places. So there's not one like that on the test.
I mean,
it makes it quite a bit more complicated.
I was just wondering, like, I don't know if you would have to like find the others, like say for like the T.
Oh yeah, for sure.
I don't know like what would go for the N, if that makes sense.
Okay, so, oh, I see what you're saying. Okay. Okay, so let's say what would the interest rate have to be to grow $2,000 into $7,000 in 10 years? If you just, we're going to stick $2,000 in some account. Oh, and I need compounded. No, I did the wrong thing. Hold on. In compounded, let's make it compounded quarterly. So we know that our amount that we want to wind up is 7,000. The amount we want to start with is our principal is 2,000. We don't know what the interest rate is. We know the time is 10 years. I forgot to put there. Sorry. So I know the time is 10 years. And I know the number of times we're compounding is 4. So my formula is going to look like this. 7,000 equals 2,000 times 1 plus R, which we don't know, over N, which is 4, to the NT, 4 times 10. Is this what you're asking me?
Oh yeah, that's what I was
basically. Or did you want to know the number? Okay, and we can also like ask for the number of years.
Yeah,
Would
can oh my bad.
Did you want the number of years?
I was just wondering where you got the 4.
Okay, so quarterly means 4 times a year.
Oh, okay.
So the main words that you'll see are like quarterly is 4 times a year. Weekly would be 52 times a year. Daily would be 365 times a year. Biannually would be 2 times a year. Monthly would be 12 times a year. That's basically what it is. And if it says continuously, then you use the PERT formula.
Okay, that makes so much sense.
Okay.
Thank you.
You're welcome.
Yeah, there's 2 time variables on this one. I think that's usually what trips people up. T is the number of years and N is the number of compounding periods per year.
Right. Right. Any other questions?